Okay, so this question here is on page 730. It's 22A, sorry, 736. Page 736. 22A, question 12. And this was a requested question. So let's have a look at it now. Suppose that a fair coin is tossed 3 times. You lose $3 if 3 heads appear, and lose $2 if 2 heads appear. You win $1 if 1 head appears, and win $3 if no heads appear. Let Y dollars be the amount you win or lose. So that there already, you know what the variable is. The variable is the amount you win or lose, right? And the amount that you win or lose is subject to the number of heads that appear. Right, so the number of heads that appears, whether it's 1 or 0 or 2 or 3, right, that predicts how much money you will get, right? So the ultimate variable, or the original variable is how many heads appear. Find the probability distribution of the random variable y. So probability distribution, key part here. Might even underline that now. And then find the probability that the number of dollars you win or lose, right, is less than or equal to 1. All right, so what do we need to do here? Well, we need to set up a probability distribution. We need this to answer this question, right? And then we need that to answer part B. So let's go ahead and do a probability distribution. A probability distribution looks like this. In order to do that, though, we need not much more complicated, but we need a bit more information to do this. And I suggest that we make a table that looks, and I'm looking at it right now, it's page 731. 731. It's a table of all the outcomes of flipping 3 coins, the variables that occur, right, the number of heads, which is our problem, and then the probability of each of those. Let's do that right now. Here's my table. I'm just going to delete that. And I need 3 columns. That's good enough for me. So in this first column will be all the outcomes of flipping a coin 3 times. Right? The middle column will be X, right? X is our variable. What's the variable here? What's the thing that's changing with flipping a coin 3 times? It's the number of heads. We could do the number of tails, but we're not interested in tails, aren't we? Right? This is heads. Heads, 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 heads. Right? So it's the number of heads. Number of heads. All right? What are the possible number of heads that can occur by rolling a dice, flipping a coin 3 times? Well, you can flip a coin 3 times and get 3 heads. Let's do that. What combination of heads, tails, and heads, or heads, heads, heads are there that'll generate 3 heads? And there's only one. It's heads, heads, heads. There's no other combination of flipping a coin 3 times where you get 3 heads other than heads, heads, heads. That's it. So I'm going to rule that off. Okay, what about when you get 2 heads? Well, the combinations must be heads, heads, tails, heads, tails, heads, and tails, heads, heads. Right? Each one of those combinations has 2 heads. Let me go ahead and just put that 2 in the middle here. What about 1? What about 1 head? Let's try it. Heads, the rest must be tails. Tails, heads, tails. Tails, tails, heads. They are the combinations of generating 1 head by flipping a coin 3 times. And there is one combination of generating no heads at all, and that is obviously tails, tails, tails. But what's the probability right? The probability of rolling each of these or flipping each of these. Well, landing on heads 3 times, right? Generating 3 heads. How many outcomes are there? Well, there's 1. There's 1 out of a total of 8 particular outcomes. So you have 1 in 8 chance of flipping a coin 3 times and having it land on heads, heads, heads. Landing on heads twice, that would be 2 out of 8. Sorry, I beg your pardon, 3 out of 8. Because there are 3 out of 8. Landing on heads once, we'll have a look. There are 3 of them. So 3 out of 8. And last we have a 1 out of 8. So that's our giant table showing our probability distribution. But we're going to do this a little bit more formally with a probability distribution table. We're just going to extract the same information and we're just going to put it into a nice table. Let's do that now. And you can see it'll look like this. Okay. Let's use AutoShape. Delete the middle. And this. Now, I might change a few things throughout, but you're just going to have to hold on a little bit, okay? All right, so what are the possible outcomes here? X, they are 0, 1, 2, and 3. So 4 of them. Didn't use AutoShape there. 0, 1, 0, 1, 2, and 3. All right, and what are the probabilities? For a 0, it's 1 out of 8. For a 1, it's 3 out of 8. For a 2, it's 3 out of 8. And for a 3, it's 1 out of 8. Okay, there's our probability distribution of the random variable x. But we're not after a probability distribution of the random variable x. We're after a probability distribution of the random variable y, which is the number of dollars you win or lose. So in order to do this, we need to change this to a y. Right? And how do we change this to a y? How do we reflect this change in our data? Well, remember, y is the number of dollars we win or lose. So let's see if we can convert our sample, or not our sample space, but rather the number of options, the particular options that could occur, and let's convert them to the dollars that they would translate to. So let's read it. You lose $3 if 3 heads appear. Right? If 3 heads appear, you lose $3. So I'm going to write -3, like that. Next, you lose $2 if 2 heads appear. Right? That's going to be, if 2 heads appear, you lose $2. So -2. You win $1 if 1 head appears. So there'd be a 1 there, wouldn't there? +1, because it's you winning $1. And you win $3 if no heads appear. So you win 3. Right? So this is a probability distribution now of our original, sample space, but it's also now taking into account how much money you would win for each particular option. Okay? So now we can change this, just this part here. We don't actually have to write x anymore. We can just write y. This is the probability of y, of the number of dollars you may win for each particular, variable, number of heads that you'd flip. Okay, so that's part A. Part B. Find the probability, right, I'm reading here. Find the probability that the number of dollars you win or lose, remember, win or lose, is less than or equal to 1. Less than or equal to 1. Is this less than or equal to 1? No, it's not. Is this less than or equal to 1? Yes, it is. So is this. So is this. These three numbers are less than or equal to 1. And so what we do is we find their probabilities and we add them together. So let's just use some formal language first. So the probability of the number of dollars you win or lose being less than or equal to $1, right, would be equal to 3/8 plus 3/8 plus 1/8. Just so you're aware, that came from here, that came from here, and that came from here. If you add 3/8 to 3/8 to 1/8, you get 7/8. So the probability of, winning or losing less than $1 is 7/8.